Welcome to the Corf Tutorials. Today we will show how to manage feeds or products. To start, let's create a new system with a pump, a control valve, and 3 pipe segments. Note that Corf includes default parameters like pressure drops and control valve sizes, so the simulation is ready to run. However, our goal is to specify feed or product conditions, so they reflect a real system requirement. Before we make any change, let's explain the concept of feed and products. In Corf, a feed or product can represent a pipe, tanks, or vessels. When we use a pipe, the feed or product pressure refers to the static gauge pressure on the flowing pipe. When we use a tank or a vessel, the pressure refers to the gauge static pressure at the top of the tank above all fluid levels. Let's assume that we have a vessel as feed, F1. And we would like to find the pressure at the end of the circuit, that is, the product pressure at TK1. Double-click on F1 and change the feed pressure to 0, as it is an atmospheric tank. The feed input dialog also allows to control the type of feed that we want to specify, and the icon to use in the process drawing area. For this exercise, select a vessel. Tanks and vessels have the same options, and from the simulation point of view, they can be used interchangeably. Change the exit nozzle relative elevation to 0.8 meters and the fluid level to 2 meters. Note that the elevation for vessels is from grade to the tangent line, whereas fluid levels and nozzle relative elevations are the distance to the tangent line, and not to grade. The starting and ending pipe elevation is determined from the connected equipment. Click OK to save changes. You will notice that the icon for the feed changed to a vessel. Now double-click on the first pipe and specify a flow of 50,000 kilograms per hour. Then go to Pipe and select a 6-inch Schedule 40 steel pipe with a length of 5 meters. Click OK. For this exercise, we're not going to add fittings, but it is important to highlight that Corf automatically accounts for the decrease in pressure due to the increase in velocity at a vessel or tank entrance to a pipe. Thus, the user typically never has to add an exit loss of K = 1 to the fittings of any pipe. Only the frictional loss of typically K = 0.5 from a vessel or tank. Double-click on the pump and specify a pressure drop of 200 kilopascals. Click OK. Then double-click on the control valve. We are going to maintain the default settings, CV = 50 and 100% opening. Click OK. Then double-click on the second pipe L2 and remove the default pipe size, 4 inches, as we want Corf to determine the correct pipe size from the sizing criteria. Change the straight length to 5 meters and click OK. Select the last pipe segment and remove the default pipe size. Click OK. Finally, select the product TK1 and remove the pressure specification. Click on Results to display relevant information, pipe flows, and equipment pressure drops. Click OK. Run the hydraulics. After a few iterations, Corf estimates the resulting product pressure using the other specifications provided, that is, the flow and inlet conditions. Let's change the scenario to determine the feed pressure instead. Assume that you have a minimum acceptable pressure at the end of this circuit and need to find the vessel pressure that would meet such requirement. Double-click on the product TK1 and specify a pressure of 171 kilopascals. Click OK. Note that at this point you have more specifications than variables, and therefore you cannot run the hydraulics. Click on the vessel F1 and remove the source pressure. Click OK. Now the variables and the specifications match, and the system can be solved. Run the hydraulics again, and let Corf estimate the required pressure at your source vessel. Congratulations! Now you know how to manage feeds or products in your simulation.